Hello, we are going to go over distance and midpoint formula. So first off, we have both formulas here. So distance should be a very familiar formula if you've taken Algebra 1 and into geometry. But distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is where x1, x2, y2, and y1 are all parts of a point or 2 points. So it's very useful to find distance between 2 points. And then your midpoint, I like to think of midpoint as the average of 2 points because that's literally what you're doing. You're finding the mean of 2 points. So we add the x coordinates together of 2 points, and we divide by 2, and we add the y coordinates together and divide by 2, giving us the middle or the average of those 2 points. This will become a brand new point. Let us practice these formulas. Here, I have a graph for us. Remember, we are working with distance and midpoint, which heavily relies on, very specifically, 2 points. We need 2 points, and so we can find the distance between any of these 2 points. And so let's make it easy first. Let's actually choose the distance from the red point here to the blue point. And what we'll find is that we actually have a really nice connection. So from the red point, we'll take those values. Let me actually enlarge that for us. We'll take those values. The red point will be 0, 0. And I'll call this my x1 and my y1. And then the blue will be our second point, which is 4, 3. And again, we'll call this one x2 and y2. First point, second point. So if I want to figure out what the distance is between these two, this black line here, the distance, I would need to use the distance formula, which we know. The distance formula, again, is the square root of x2, not plus, minus x1, quantity squared, plus y2 minus y1 squared, and that will give it to us. So let's actually do this. If I want to just plug these values in, we get distance is equal to the square root. X2, in our case, is 4. So we have 4 minus 0 is x1 squared, plus y2, 3 minus 0 as well. I did choose an easy one just to start us off here. And from here, we just simplify. Now, since we do have calculators available, you could just plug this all in. You need to watch your parentheses really well. Otherwise, your calculator will not read this correctly. But we get 4 squared plus 3 squared. And this is actually a very famous distance, but we get 16 plus 9, or the square root of 25. So it works out really nicely when we get a distance of 5. So in our case, the distance, this black distance here, is a distance of 5. Okay, I don't want to overshine this with just the distance formula. I know that's what we're focused on. It is all point-based, but I do want to emphasize that we can actually think about this as the Pythagorean theorem. They are one and the same. The distance formula emphasizes point-based work, but if we can build through distances, especially the horizontal distance versus the vertical distance, then we can use Pythagorean theorem, right? We have a length from the x value to the x value is a value of 4, and a height here of 3. So we could create right triangles. And this is a really quick way, especially for looking at Pythagorean triples, to get into what the distance is. We either use side lengths with the Pythagorean theorem, or we use points for the distance formula. All right, let's try another one. And this time, let's go from blue to purple. Let's try that one. So from blue to purple. And it actually doesn't matter which is your x1 or x2. You just have to be consistent. So let's try that. So let's just say our blue, again, is was it 3, 4 or 4, 3? 4, 3. And the purple is 7, -2. Okay, sometimes it doesn't actually, it's not entirely pretty every time. Like the square root of 25, we might get a weird square root, which is fine. Again, we have calculators in our hands, but we can also simplify the square root. So let's take a look at this. We get, and I'm gonna choose the blue to be my first point and the purple to be my second. So I'm gonna use 7 minus 4 squared plus -2. Since we started with the 7, we have to start with the same y coordinate. -2 minus 3 squared. So in this case, I will do it all by hand, but again, you have a calculator. So 3 squared plus -5 squared. And we get 9 plus 25, which gives us a total of the square root of 34. Now, we look to see if this can simplify, and since there are no perfect squares within 34, the square root of 34 is our final distance. And if you want to check that, you can always use a factor tree to kind of prove to you that it doesn't break down. So we get the square root of 34. So that distance is the square root of 34. And again, we could have emphasized that we have a vertical distance versus our horizontal distance. Well, the vertical distance goes from 3 down to -2, which is a distance of 5. And the horizontal distance goes from 4 to 7, which is the distance of 3, which is what we thought. That's why we get 9 and 25, or we get 3 and -5. There is that you can just count it, which is very valuable here. So if you are more comfortable with the Pythagorean theorem, you can always switch distance to that if you're given a graphic. All right. Last thing I'm going to do is just kind of find the midpoints between things. And the midpoint, again, is just the average of 2 points. So let's use the green and the blue here. We keep referencing blue. Let's use it again. So if we want to figure out what the midpoint is between these two, these are actually just horizontal. So we don't really need to consider the vertical values. They're both at a height of 3. So taking that into consideration, it goes from -3 to 4. So we know that somewhere we should be able to eyeball it. It's probably going to be about there. But if we want to, let's run through what this actually becomes. So again, the midpoint formula. Midpoint. Midpoint is the average of 2 points. So x2 plus x1 divided by 2. And your second coordinate would be y2 plus y1 divided by 2. So in our case, we are given 2 points. One point is at -3, comma 3. And our second point is at 4, comma 3. Those are those 2 points up here, the green and the blue. So let's just go ahead and plug this in. So our new coordinate will be adding the x's together. So we get -3 plus 4 divided by 2. And we also get 3 plus 3 divided by 2. And we add those together, you get 1 over 2, and we get 6 over 2. Simplify, so we get 1/2, and we get 3. And again, the height should stay the same because they are horizontal with one another. And if we go up here, we get that point at 1/2. That's exactly where we thought it was going to land, at 1/2 here. That's this point. And the height, again, is 3. So that directly correlates with our midpoint. This would work with any of the 2 points that we connect. We can find the distances among them or between them, and we can also find the midpoints. Now, again, really big emphasis on point-based. Distance and midpoint use points. It does not mean that we can't alter it into using the distance or the lengths of a right triangle. So we can open up the Pythagorean theorem. Counting is very valuable, especially if you have a graph in front of you. You should be able to estimate, and especially with ACT style questions, you should be able to use process of elimination really quickly. Last thing I'll mention is distance always will be positive. Whenever we take the square root of something, if we want to keep it to be a real number. And so that's why we have to square our values here. That's not why, but squaring the values will make it positive. So you should never have a negative value underneath your square root for distances. Keep that in mind. Practice using your calculator with this, and practice the problems that come with this.